Good morning, everyone. My name is Courtney Piper. I serve as Executive Director of the Tennessee Advanced Energy Business Council, and we are pleased to welcome you today to this year's TVA Lunch and Learn, hosted by the Tennessee Advanced Energy Business Council and our partners at ETEC, the East Tennessee Economic Council. For those of you who are not familiar with the Tennessee Advanced Energy Business Council, or TAEBC, we champion advanced energy as an economic development and job creation strategy in Tennessee. Our definition of advanced energy is technology neutral, so anything that makes energy cleaner, safer, more secure, more efficient, it's in the tent. And we focus on energy innovations as a means to economic development and job creation. We do this in a couple of different ways and have a couple of commitments to our members and our stakeholders. First is to make sure that Tennessee becomes the #1 state in the Southeast for high quality jobs. Next year, we'll be releasing our 4th Advanced Energy Economic Impact Report, where we detail the breadth and depth of Tennessee's advanced energy economy. In 2021, which is our last report, we found that advanced energy employs nearly 394,000 Tennesseans with over 20,000 businesses and contributes nearly $46 billion to our state's GDP. We also host events like this and our annual Opportunities in Energy, which will be November of this year, as well as launching our podcast, Energizing Tennessee, powered by First Bank, to help share the good news and opportunity in Tennessee's advanced energy economy. We also partner with TVA and our local power companies to help make those companies energy companies of the future. Our utility landscape has shifted so dramatically, and there's so many exciting innovations that can make our lives and life easier and more efficient for all of us. So making sure that we share information about those latest and greatest technologies, policies, and what have you, to make sure that we can sustain that leadership role in Tennessee as a national leader in our advanced energy economy. Third is to foster the growth of Tennessee's energy entrepreneurs, startups, and technology. We partner with Launch Tennessee to do this through a program called the Energy Network. One of the signature items in that programming is our Energy Mentor Network, where we provide mentoring to energy entrepreneurs across the state of Tennessee, including some of our advanced energy focused accelerators and incubator programs like Innovation Crossroads at Oak Ridge National Lab and the Spark Clean Tech Accelerator and Incubator at the University of Tennessee Research Park. And lastly, we want to share our experience with the federal government and those within the Department of Energy. We have a lot of experience in the experience and expertise in advanced energy in the state of Tennessee. So to the extent possible, we want to inform those big picture, big goal national energy agenda items and programs, and make sure that we are able to grab our fair share of some of those exciting investments that are coming down from the federal government. So that's a little bit about the Tennessee Advanced Energy Business Council. I'd like to introduce our partner in this, Tracy Boatner. She is the president of the East Tennessee Economic Council. So Tracy, go ahead.
Hi, good morning, Courtney, and good morning, everyone. Really appreciate the opportunity to partner with the TAEBC today to hear more about Clinch River Project happening on TVA's Clinch River site. So looking forward to hearing from Greg. I'll start just by telling everyone a little bit about East Tennessee Economic Council, or ETEC. ETEC is a nonprofit membership organization created to grow the economy by telling the region's story, particularly as it relates to the federal government's missions happening here in East Tennessee. And it's a story about normal, ordinary people who go to work every day and support extraordinary missions that are happening here in East Tennessee. And they have an impact not only on this region and on our state, but on the nation and on the entire world. And we tell these stories about our federal assets, not only to inform, but also to create synergies and connections that catalyze growth in the region. And one of our region's biggest assets, as you know, is the Tennessee Valley Authority. And we're very excited to hear from Greg Boerschig today with the Tennessee Valley Authority, and appreciate the opportunity for the partnership. If you are interested in hearing more from TVA about their new nuclear program, Greg will be speaking at ETEC's Nuclear Opportunities Workshop, and that's scheduled for August 1st and 2nd here in the Oak Ridge corridor at the Airport Hilton in their convention space. And Greg will be there and speaking about this Clinch River project. And Jeff Lyash, TVA CEO, is also scheduled to be there. So I think we're going to put more information. A link will be in the chat if you're interested in learning more about the Nuclear Opportunities Workshop, or NOW conference. And with that, I will turn things back over to Courtney to introduce our speaker.
Great, thanks, Tracy. All right, without further ado, our featured speaker for our annual TVA Lunch and Learn is Greg Boerschig. Greg is the Vice President of the Clinch River Project at TVA. He brings over 40 years of extensive experience in the nuclear industry, holding a Bachelor's of Science in Chemical Engineering from Clarkson University and a Master of Science in Mechanical Engineering from New York's Polytechnic School of Engineering. Greg has held leadership positions in various organizations and regions. Currently leading the development of a standard design for a small modular reactor at Clinch River, he also oversees quality assurance and staffing for the SMR development while contributing to the advancement of the nuclear industry. Greg Boerschig with TVA, the floor is yours.
All right, thank you very much. And let's see if I can share my screen here. All right, can everybody see the slideshow? All right, I'm assuming you can. Nobody told me no. So I'd like to talk this morning about the Clinch River Project, and I'll touch on the new nuclear program. So first off, what I'd like to talk about is an overview of just exactly what an SMR is, so we're grounded on the discussion. Small modular reactor is typically defined by its size, its power output, and construction techniques. It's smaller, roughly 1/10 to 1/3 the size of a current operating plant. The power output is typically 300 megawatts or less, compared to a currently operating plant of around 1,200 megawatts electric. These plants are constructed using modular techniques, which lends to the efficiency and cost savings associated with building these plants. Generation 3 plants, we'll talk about two different types of small modular reactor. A Generation 3 plant is a light water cooled SMR, and that's cooled by just water, just like what comes out of your tap. Generation 4 plants are cooled by some medium other than water, such as gas like helium, or metal such as liquid sodium or molten salt. So I'll reference those as we go forward. All right, so the first thing, let me, all right, so no, it didn't, must have went back, apologize for that. So let's talk about why SMRs, and what's the attraction to SMRs, and why not just build large plants? Well, SMRs, like all nuclear plants, have zero carbon emissions, which makes them good for a decarbonization strategy. What they do is they add high reliability, availability, and capacity to a grid of the future. Now, a small modular reactor is typically much simpler in their design than larger plants. So that simplifies the licensing process, construction, and operation. Now, although they're simpler, they are packed with lots of innovation and high technology. So it's an advanced reactor. Also, because of the smaller size and reduced capital requirements, you don't have to bet the company to build one of these. Nuclear plants of any size are very efficient in land utilization and have lifespans of around 60 years, where wind and solar, their lifespan is about 20 years. The life of nuclear plants in operation today operate upwards of 80 years, and some are even evaluating for 100 years. These plants are constructed of the same materials, same process, so it's expected they'll have similar lifespans. Generation 3 plants can have some advantages over Generation 4 plants depending on your horizon for planned construction. Generation 4 plants, they are advanced. They are a more advanced generation of plant. They have capabilities for district heating, hydrogen production, a number of advancements. But Generation 3 plants deal with known technology, fewer first-of-a-kind features, so they're less risk for construction currently. They also use the same fuel that are used in current plants today, and that fuel also comes from reliable American sources. And most importantly, they're deployable this decade. But also, why is TVA looking at the GE BWRX 300 and why Gen 3 at all and not waiting for Gen 4 plants? Well, with our decarbonization strategy, which I'll talk next, having something that's deployable this decade is important. Also, the GE BWR they've been producing boiling water reactors since 1950s. They started designing these, so they have over 7 decades of experience. In fact, the X in BWRX 300 stands for the 10th generation of boiling water reactors. So there's a long history of fine operation for these plants. There are fewer first-of-a-kind features, which again lowers risks. And this design is based on the ESBWR, the Economic Simplified Boiling Water Reactor, and that has 30 years of design and licensing experience into it. These plants, though, the small modular reactor is 90% of the volume, so it's a much smaller plant, has 50% less concrete and steel, so makes for ease of construction, and 50% less equipment. Also, these plants utilize full passive safety system, so you don't need any power to mitigate the low probability accident scenarios that are evaluated in the design of these plants. In fact, there's no need for diesel generators because none of the safety systems require any power. Another safety advantage is for current plants operating today. They utilize a emergency planning zone of 10 miles. This plant, it's at the site boundary, which is a significant safety feature. It uses the same fuel as BWRs in operation. So this fuel, it's the same size, same exact fuel that we would put in the Browns Ferry plants. And as I mentioned, it utilizes modular construction, and it does have load follow capability, which is important for what I'll talk about next. So how does an SMR fit into TVA's long-term strategy? Well, in order for TVA to achieve its aspiration of zero emissions by 2050, or net zero carbon emissions by 2050, there's 5 areas of technology innovation that are being pursued, and they're in the upper right-hand corner of the slide you're looking at. SMRs can load follow, as I discussed, which is important because it allows them to complement renewables quite well. It should be noted that TVA is pursuing all 5 areas of innovation. But with what is currently known today, only Generation 3 nuclear technology and pump storage are deployable within the next decade. TVA has projects in each of these areas to help advance the technology, and the industry is pursuing these technologies vigorously. TVA monitors the advancements in these areas, and if need be, we can modify our plans to help keep rates low and the reliability high. Let's still go on to the next. Okay, there we go. Okay, so how do SMRs complement renewables? Well, because of the inherent availability limitations of renewable generation due to the natural variations in wind and night and day, grid fluctuations can occur with a strategy of just renewables alone. In the case of wind, those fluctuations can be rather instantaneously. A reliable source of generation is needed to flex with those variations to maintain grid voltage and demand. Until a reliable, cost-effective storage option becomes available, SMRs can play a vital role in responding to renewable source generation availability. Because SMRs are built with load following capability, they can respond to those variations in grid uh, voltage and power demand, and as the renewable load changes due to these external conditions. Pump storage can also play a role in complementing the renewables in meeting this grid demand. So if the goal is to have a decarbonized generation source portfolio, nuclear and pump storage can play a vital role in supporting a highly reliable grid of the future. Did it change? There we go. So let's talk about the Clinch River Project. So where we are today with this project is we have completed an NRC approved, we had obtained an NRC approved early site permit that was obtained in 2019. We also have a programmatic environmental impact statement that was obtained in 2022. Both those documents, or both those vehicles, were developed not specific to any one technology. So we could pursue any particular new nuclear technology, provided they're less than 800 megawatts. The board, TVA board, has approved $200 million to help explore additional technologies and locations for additional siting. This allowed us to enter the planning phase of project development. So let's talk about that. So this diagram is our decision gate process, which we use to ensure that the project does not progress to the next phase until all the design work, the scoping, estimates, and planning fully meet established criteria. Passing each of these decision gates requires board approval. If a gate is not met, you'll see that there are off ramps at each of the decision gates, and that is to ensure that if criteria is not met, additional work to meet the criteria is pursued, or we could either delay or stop the project if things are sufficiently off of target for budget or schedule. As I mentioned earlier, we are in the planning phase. That was attained in 2022, and what we're doing in this phase is we're progressing the design. So it should be progressed to about 50% complete before we're ready to support Decision Gate 2. We're preparing the construction permit application, and we'll submit that to the NRC. We're also completing a AACE Class 3 cost and schedule estimates, and this work is technology specific. So for the early site permit and the programmatic environmental impact statement, those were not. This is technology specific to the BWRX 300. However, we still are evaluating this technology such that if we cannot demonstrate the economic viability of this, then at Decision Gate 2, we could end up taking an off ramp. Decision Gate 2 is where the board approves this to become a fully funded project. Decision Gate 3 is where we would seek board approval to begin construction activities. And you can see from this chart that it's about 2 years between Decision Gate 1 and Decision Gate 2, and the same for Decision Gate 2 and Decision Gate 3. That can vary as high as 3 years, or it could be a little less than 2 years. And then right now we're planning out a construction window of about 5 years. Now these plants ultimately should be able to be constructed in 3 years or less, but you know, we are planning for some extra time. This number though could come down if we get to the point where we make a decision to pursue construction. Now, if TVA does pursue construction such that the evaluation proves that the BWRX 300 is economically viable, TVA does have the nuclear power experience and construction experience to be successful in this area. TVA operates the third largest nuclear reactor fleet in the United States. We have a good operating experience. Also, TVA's Watts Bar Unit 2 was the nation's first reactor in the 21st century, and that entered commercial operation in 2016. TVA has other nuclear construction experience. We replaced steam generators, which is a huge job at both the Watts Bar and Sequoia stations. We also did a power uprate for the Browns Ferry plant. In addition to nuclear construction experience, TVA has around 900 active projects totaling $12 billion in approved funding for construction of things like combined cycle plants, refurbishment projects at hydroelectric stations, transmission infrastructure. So TVA is very active in construction. So let's talk a little bit about what Clinch River means to various stakeholders. So to TVA, a successful Clinch River project definitely supports the decarbonization journey. As I talked earlier, it provides a reliable power source to meet load growth demands and stabilizing the plant with a larger portfolio of renewables. To the Tennessee Valley, this will provide deep carbon reductions without compromising high reliability and low rates. And it's also a good source of jobs, not just for constructing, but TVA has stated publicly that if we build one, we'll build many. So if you're building upwards of 20 small modular reactors, that's a lot of great construction jobs. And then for individuals to operate the facilities once they're constructed. To the nation, it's also very important. There are many utilities that are standing in line to be the second to build a small modular reactor. Very few have stepped forward to be the first because of the history of plants being built and not meeting budget, not meeting schedule, and many really never got off the drawing board or were canceled early in the construction process. So it's very important for those first movers, as we call them, that are stepping out to be the first, to be successful, to prove that nuclear can be a viable option and can be built safely, on budget, and on schedule. That will serve to draw out those fast followers and create a magnificent industry for the nation. So if we do pursue construction, why do we think we can be successful? Well, as I mentioned earlier, the GE BWRX 300 size and complexity compared to large nuclear plants, it's much smaller. It's a much simpler design. So in fact, it probably doesn't even qualify as a mega project. So the ability to manage a construction project like this is less complex than for a larger nuclear plant. And as I mentioned, because of the reduced capital costs, you don't have to bet the company to take on a project like this. Industry experience. The nuclear industry is very liberal with sharing of information on operating experience, construction experience. So we have lots of information for Watts Bar Unit 2 construction, VC Summer, Vogtle, other nuclear plants around the world. In addition, non-nuclear plants such as combined cycle experience and other projects. The other thing to note is that we are part of a collaboration agreement with Ontario Power Generation. Ontario Power Generation is going to be building this exact same plant at their Darlington site, and they're about 1.5 to 2 years ahead of us. So all that construction experience and lessons learned we'll be able to benefit from. Engineering approach, this BWRX 300, the GE BWR fleet has a very mature supply chain, and well over 90% of that supply chain can be used or modified to meet the needs of the BWRX 300. Also, we're engaging construction companies into the design, so we're building constructability throughout the design process. Also, we're engaging operations and maintenance personnel to ensure that the plant is not only good on paper, not only can be constructed, but also can be operated and maintained. And then the standard design should be about 95% or greater before construction resumes. And that's to make sure that we've fleshed everything out and we're ready to proceed if Decision Gate 3 is approved. We're also using a different regulatory approach than some of the other recent nuclear plants. There are two regulatory approaches. One is 10 CFR 50, the other is 10 CFR 52. 10 CFR Part 52 is a combined construction permit and operating license. Now, that's great because the external challenges occur once at the beginning of the process, and once the decision is made to start construction, it's pretty much a straight shot to putting the plant online once construction is complete. But it's an approved design, so any field changes that are needed throughout the design process, they amount to a license amendment, and that's quite time consuming when you have hundreds or thousands of construction workers standing around idle. We chose to go with 10 CFR Part 50, which has a separate construction permit and a separate operating license. So what that will allow us to do is this is a first of a kind plan, so there will most likely be requirements for field changes throughout the construction process, and then we can make those changes in the field and then submit those changes as part of the operating license submittal late in the construction window. So that's we believe that's beneficial for first of a kind technology construction. Also, innovation, there's lots of construction planning such as virtual reality tools, 3D and 4D modeling. 4D modeling is 3D modeling plus cost. Composite technologies, modular construction, several innovative contracting strategies such as integrated project delivery. What that does is it allows all those involved to share in both the risks and the reward of the plant. So it kind of helps developing a strong team to develop the construction planning and then execute the construction process. The other thing is the decision gate process, also vitally important to making sure that we're ready to go if we deem that we're going to pursue construction. And I believe that was the end of the presentation. So I'll stop there and open it up for questions. And let me stop sharing so we can, if that would help.
All right, thank you, Greg. As a reminder to our attendees on the Zoom, please use that Q&A function to type in your question and I will moderate the Q&A session. Greg, while we have folks thinking about their questions, can you talk a little bit more about workforce, both the needs and how the needs are different from, I guess, what you would call your traditional nuclear power plant?
Yes, yes. Well, I guess there's two things associated that need to be discussed when you talk about workforce and building a nuclear power plant. First, there's the construction aspect of this, and one of the things, in fact, ETEC has a lot of activity going on to evaluate the needs for not only construction but operating of various facilities. There's a lot of work going on in the Tennessee Valley. So there's a significant resource drain. And plus, this is all happening at a time where a lot of the workforce is exiting the workforce, a lot of that high skilled workforce. So very important to start developing sources of, of personnel to complete the construction project. For the plant itself in operation, and I think this is what you were looking for in your question, there is a lot of technology in this, more digital applications than before. So there will be some changes in the workforce requirements. Now, these plants by design are simpler, so it will take less people to operate these plants, but there will be a higher reliance on INC technicians, digital capability, so on and so forth. Did I answer your question?
You did. You did.
Okay.
Greg, we've also had a couple of folks ask if they can get a copy of your presentation. Is that could we share your slides with folks who registered for this webinar?
Yeah, I believe it's been reviewed. So
Okay.
yeah. Mm-hmm.
Great. Great. And also, there's a follow-up question there. Is there a conceptual design that is available?
Well, there are some design views on the internet. You can type in BWX 300 and you'll get some very high level pictures. I certainly can't share the design because it's, we are in a technology collaboration agreement with General Electric, Ontario Power Generation, and Synthos Green Energy out of Poland, but the rights are held by General Electric. So we can't share that. I can tell you that the design right now is we're nearing the end of conceptual design, and towards the middle of this year, we'll be starting preliminary design, and that'll take us through the end of 24, where we get into detailed design. And really, there's crossover. We've actually started some site-specific design. So there's all aspects of the design ongoing. The design right now is about 30% complete.
Great.
Mm-hmm.
Also, another one, how do vendors and companies get on the list to provide services to TVA for the Clinch River? I guess it would be the Clinch River Small Modular Reactor for the Clinch River site.
Yes. I would contact the supply procurement organization. That's who we've used. And I think there'll be a lot more to come as we go forward. Some of it will go through General Electric. Some of it will go through TVA. Some through the architect engineer once we select an official architect engineer. But I think I would go through the standard supply organization at this time.
Okay. Another question, what is TVA's current projected levelized cost of energy for the first SMR?
Yeah. Right now we're still doing the estimates on that, so we really can't give the number, because with the design maturity at where we're at, the variability is significant. Our early projections is that the first of a kind plant will be high. Most first of a kind plants are upwards of 2 to 3 times the cost of the nth of a kind, and really what you want to do is build multiple plants, because that you develop the engineering is complete. You work through all the issues there, work through your licensing challenges, also work through all the construction challenges, and then you allow that supply chain to mature, which allows the cost of your nth of a kind to come down over time. So what I can tell you is our current projections is that the nth of a kind plant will be cost competitive with energy sources of the future. So what does that mean? Right now, if we were to do comparisons with straight gas, you probably couldn't compete with straight gas. But when you start looking at gas with carbon capture and sequester, it competes well and renewables and other sources of the future. But we're continuing to work those estimates, and really that is really behind the decision process at decision gate 2 when we make that decision become a project. Is not only the first of a kind a reasonable cost, but will those nth of a kind costs compete well with other forms of energy?
Okay, great. Well, Greg, we've got about 25 minutes and we have a lot of questions, so I think we'll get through these. Next question, Greg, you talked about the potential for additional SMRs beyond Clinch River. What's the timeline look like for those plants? Are we going to finish Clinch River first as a proof of concept?
Yes. Yeah. So right now the plan is to complete Clinch River 1. We do have actions in place to evaluate other sites. So we are actively looking at other sites. We really can't discuss that until all that evaluation is complete and we're prepared to make public statements. But we are prepared to go beyond Clinch River if it's deemed this SMR is deemed to be economically viable. And I think Jeff Lyish has mentioned publicly that if we build one, we could build upwards of 20 plus small modular reactors.
Okay. And Greg, we've got just a couple of questions again related to the timeline and what's happening on the site. So I'm going to try to condense 2 or 3 questions into one. We've got some appreciation expressed for you updating us on the Clinch River SMR. What is currently happening at the actual site in Oak Ridge, and what activities are planned on the site in the foreseeable future? So if you can just kind of go through any preliminary activities that might be going on there now, like site prep, testing, mock-ups, that sort of thing, just sort of take us through the general timeline for that site and what's going on now and what's going to happen in the future.
So that's a great question. Thank you. For any construction to start, construction is defined in NRC guidelines. So we are somewhat limited to what we can do before we have a construction permit. Now, there are some things that we can do regarding site preparation and things like that, but we really want to get through decision gate 2 before we commit to those types of resource. Now, what has happened? We have constructed a bridge, and the bridge was built to accommodate not only large numbers of people coming to the site for construction, but also to accommodate heavy equipment. Some of these components are quite large, very heavy, and the bridge was designed for that. So we do have that. Most of the work ongoing at the site now is characterizing the soil structure, seismic analysis, and things like that that will support the building designs and things like that. But no real earth movement or things like that. All that sort of thing would happen following decision gate 2.
Okay. All right, we've got a very specific question here, so bear with me. Digital twinning requires a sizable investment in instrumentation to provide feedback to the digital twin. Is there strong interest in having digital twins for SMRs to assure operational feedback is readily available to rapidly improve future versions of the design? Is TVA considering a digital twin strategy for the first AP300?
Well, we're building the BWRX 300. The AP300 is a Westinghouse product that was recently announced, I think, within the last couple months. But as part of the standard design, digital twin, the 3D model portion of the digital twin is part of the standard design. And then part of our site-specific design is where we would add other things that we would want monitored, what would be needed to integrate other business processes to align with the plan so you can optimize PM strategies, bill of materials, all sorts of capability of digital twin, but that is part of the design specification.
Okay, nice. How is TVA pursuing Gen 4 reactors for demonstration?
Well, TVA does have um, an agreement, and it's not the same as for the BWRX 300 with the Hermes reactor that's being built at Oak Ridge. That reactor is TVA has support functions, but it's not. We don't have a stake like we do in the BWRX 300. TVA does monitor though the progress of Generation 4 technology. So in fact, we produce a report every year that goes over the advancements in each of these progress. And that's what I was talking about earlier, is that we're always looking to see what is best for the ratepayers of the Tennessee Valley. So if some of that technology advances to the point where it has greater promise, then we may alter our plans for the BWX 300. However, when you look at the horizon for those plants and Gen 3 technology, there's really, for serious availability, you're probably looking at about a decade difference between Generation 3 and Generation 4. But we are closely monitoring all the advancement in those areas and are prepared to modify as appropriate.
Okay. That report you mentioned, is that something that's available on TVA's website? Or is it an internal?
I think, well, I know it's internal. I don't know of the availability of that external, but it is something we do for our internal business purposes for sure.
Oh, great. Okay, I'm going to go through some of these questions. Okay, I'm particularly interested in the MSR design. I think that's supposed to be SMR. I'm particularly interested in the SMR design, currently replacing SMRs at SQN, and have interest in potential input to this portion of the design.
Okay,
you
so
have a reaction to that question, Greg?
SQN is Sequoia Nuclear Station, and I believe what the question is asking, when the current fleet outlives its lifespan, what would be, what would replace it? Mm-hmm. So, as I mentioned, to achieve the net zero carbon emissions by 2050, nuclear will have a role in 2050 and beyond. And when you look at the I haven't really done the math, but I believe that Sequoia will go beyond 2050, and to replace the current fleet, that will be a different set of decisions of how we will do that. But when you look at that much generation going, just to put in perspective, when I talked about the size of an SMR, it takes 8 small modular reactors to replace all the power generated from the 2 reactors at Sequoia or Watts Bar. It takes 12 to replace the power generated at Browns Ferry. So that would be a lot of construction to replace all those plants. So we could replace them with just a larger fleet of small modular reactors. We may have the experience at that point to pursue a larger plant. There could be different technology that we look at. So that decision hasn't been made. But when you look at the decarbonization strategy and to maintain a reliable grid, nuclear will play a large role in the future. What that is, I really don't know to speak about it. And I think a lot of those decisions have yet to be made.
How long will it be before there are smaller units to power a neighborhood development?
Well, right now there are designs that are 50 megawatts or less, and they're called microreactors. And there are several vendors in the United States that are pursuing designs for microreactors. Right now, though, the plans for small reactors like that are for installations, industrial installations, also things like military outposts that are in the Arctic or Antarctica. Lots of value in those sorts of things. I don't believe that those designs and marketing even has progressed to the point where they're considering it for neighborhoods.
Okay, but that would be a micro reactor and not a small modular reactor.
Yeah, depending on the size of the neighborhood.
Mm-hmm. Okay. Does TVA have employees consulting / working with OPG in Ontario?
We do. We do have the technology collaboration agreement that was publicly announced, and that is for working on the design and all the aspects of the technology that related to the standard design. We also have agreements with OPG, which were also publicly announced, where we're sharing information and resources and things like that. So if you look at just big picture, OPG is in front of us in design. Well, we're right together in the design, but in planning and constructing their reactor about 1.5 to 2 years. So we're going to learn a lot from them on construction, planning, all those sorts of things. But OPG, they have all can-do reactors, which they refuel online. So operating a BWR, they don't have that experience. We have Browns Ferry, so we're able to provide them with refueling experience to develop their plans, training for operators, running a boiling water reactor. So it's a very good relationship. When you look at the strengths that each organization possesses, and both CEOs of TVA and OPG are very committed to their organizations working together.
Great.
Mm-hmm.
Just remind our attendees, when is the commercial operations date for the Clinch River site, for the Clinch River reactor?
I don't believe that's been publicly announced yet, and it really comes down to defining the schedules that we have. If you look at, I had that decision gate up there. You
Yes.
could probably do the math and be within the ballpark of a year or two, but we're still developing the schedules, so really haven't announced a commercial operation date.
Okay.
And in fact, I think it's important to note that until we get to decision gate 2, we're still evaluating the viability of the technology. So that's important to know. Mm-hmm.
Okay, thank you. All right, given the SMR power generation is equal to prior plant iterations, what improvements / comparisons are expected regarding legacy waste recycling and disposal with this newer SMR technology?
Okay, I missed a little of the front, but I believe the back half regarding waste disposal is really the thrust of the question.
Yes.
So this plant uses the same fuel as a boiling water reactor. So currently operating boiling water reactor. So you can expect that the operational waste to be about the same. At least with respect to the fuel cycle. When you look at the design, the advancements that have been made in operation, in safety, the fewer amount of equipment, the amount of low-level waste generated through operations and maintenance should be lower as well. So I would expect that the waste generation for this plant will be per megawatt, that is, will be about the same or less than for a large plant. I know there's been some reports and some studies done, I believe, by Stanford University and others that talks about, but it really is looking at generic SMRs, and the industry has taken exception to some of the things in those reports. But when you look at this particular plant and what's known about this technology, I think it's safe to say that the production will be about the same or less given the smaller size and less equipment.
Okay. Will the SMR have a 2-year fuel cycle?
This plant can have up to a 2-year fuel cycle. So I think what we're also evaluating is what is the optimal fuel cycle. So there are advantages to 12-month fuel cycles that you don't have with a 2-year fuel cycle. But all that is being evaluated, and what is the optimal strategy for this plant. Could be 1 year, could be 18 months, could be 2 years.
Okay.
Mm-hmm.
Okay, let's see here. Greg, I think you've already answered this, but it might be worth repeating. From the SMR location planning standpoint, are you focused on supporting large industrial customers, residential, or more energy hotspots?
So this is beyond Clinch River, if I understand the question correctly.
Yes. Yes.
Yeah. So well, I think the answer is yes to all of the above. And when you look at siting a nuclear plant, there's a lot of factors that goes into it. Of course, you do want to look at where is the energy demand concentration. That's certainly a factor. But then you have to look at seismic concerns, environmental concerns. There is a lot of restrictions on siting a nuclear plant that you don't have for, say, a combined cycle and other types of plants. So it really is a marriage of all of the above, plus the specific requirements for siting a nuclear plant.
Okay. And if you recall, I stumbled around this acronym. I thought it was SMR, but the person who asked the question said they are interested in the moisture separator reheater design at the SMR.
Oh, okay. Okay.
If you could just talk a little bit about that.
Sure. Well, right now the turbine building and all the balance of plant components are being designed. This plant will be, there's 2 low pressure turbines associated with this design. Current designs do involve a moisture separator reheater, but we have not finalized the balance of plant design for this yet. But I would anticipate this to be, there's one of the advantages to this plant in terms of our ability to estimate is the turbine building and all the associated components with the turbine generating cycle, very similar to a combined cycle and to what we have in our current nuclear operating plants. So I would not expect any significant differences in the plumbing. Certainly some advancements in the digital control systems, but I would expect that type of hardware to be very similar. But we are still designing, so there could be some changes.
Okay. And how many employees are expected to be required for each SMR plant?
Yeah, that's another area that is still being evaluated. So I guess the thing that's important to note, if you look at current nuclear plant, what's happening in the industry today, there are plants in the country that are dual unit, 2,500 megawatts at the site, top decile performance, top decile staffing, and they're shutting down because they can't compete. And then we come along with a 300 megawatt plant. So staffing is going to be a significant focus. And that's why the design, it's so important to design your design security in everything from the ground up. Design operation, design when you select your components, don't have this massive number of different components. Really use standardization so the required numbers of people are optimized to the extent possible. but there really isn't a number to disclose. But it is important to seek the most efficient staffing possible.
Okay, great. And Greg, I think we've got time for two more questions. So one of those questions is our attendee had a question about one of the first slides that you had comparing Gen 3 reactors to conventional reactors for things like concrete needs. Wanting you to explain a little bit more about the percent less and just maybe go through some of those comparisons a little bit more with a little bit more detail and related to costs and units of measurement.
Okay. Yeah, I could answer it multiple different ways. But really on the concrete and steel, it's really a function of size. And I think that was the important message of that slide. When you look at a plant that is 90% less volume than its large large counterpart, that's a significant reduction. When you look at the reductions in equipment, because I think one can say, well, all you're doing it's going to need a lot of the same components. It's just smaller. But the thrust of the design was to make the design simpler. So there's far less equipment. So for example, I spoke about passive systems. In a current design plant, it has multiple trains and multiple systems to mitigate the consequences of a unlikely low probability accident. For this plant with passive systems, very few. In fact, very few in support of this design. Plus the fact that everything is passive, there's not a lot of motive force needed for the equipment. So the plant design inherently takes care of itself. So things like that lead to those simplification is what leads to the reduction in equipment. I know that's a very high level, but I did want to leave room for one more question.
Okay, great. And our final question, Greg, comes from our co-host, ETEC. What can this community do to support TVA and its efforts to make this SMR plant a reality?
Great question. Well, I'll tell you, speaking for the Clinch River area and Oak Ridge, I don't think we could have asked for a more knowledgeable community when it comes to supporting nuclear technology. The Oak Ridge area is rapidly becoming the hub for new nuclear, not just commercial power generation, but fuel manufacturing, isotope production, government installations. So the community is very educated, and they ask a lot of great questions. So through our interactions with ETEC, as we have presentations and things like that, the questions that we get, we meet actively with the local politicians and things, so they're very helpful. I think what they can do is stay informed, participating in forums like this, providing great questions like were presented to me today, interacting with their local politicians, and just being informed, and then make sure that informed decisions are being made by the community. But we couldn't be any happier with the community support that we have and the knowledgeable personnel living in the area.
Okay, great. Let's see. Well, Greg, we have reached the end of our webinar. I want to thank you very much for joining us today. This TVA Lunch and Learn is an annual event that the Tennessee Advanced Energy Business Council partners with TVA on. So our attendees, our members, our stakeholders, if there are other questions or topics that you have for TVA, let us know. We are very responsive and to our membership. So this is your opportunity to have a direct conversation with the folks at TVA who are working on some of these projects and programs. So Greg, thank you very much. If you all like what you heard today, we encourage you to go to our website, become a member, tnadvancedenergy.com, and also take a listen to our podcast, Energizing Tennessee, that's powered by First Bank. It's available on Apple Podcasts, Spotify, or wherever you get your podcasts. To close us out, Tracy, would you like to remind our attendees about the Nuclear Opportunities Workshop?
Sure. Thanks so much, Courtney. Again, it was a pleasure partnering with TAEBC today to learn more about TVA's Clinch River Project and the small modular reactor project that's planned for that site. Thanks so much to Greg for his time and for all of the knowledge that he has shared with everyone in this meeting today. If you want to hear more from Greg and others in the nuclear industry, please join us at the Nuclear Opportunities Workshop or the NOW conference. You can visit eteconline.org to learn more about that, and hope to see you there.
Great. Thank you all very much. This concludes the webinar.